Okay, this is some more problems from section 9.2. This is number 28. And consider the power series, and they give you, well, the power series is summation n equals 0 to infinity of a sub n x to the n, where a sub 0 is 1 and a sub n is defined as 3 over n times a to the n minus 1 for n greater than 1. This defines the coefficients recursively. That's what we have over here. So find the first four terms in the general term for the series. So we have to find the coefficients. It's going to be x of 0, x to the 0, x to the 1, x to the 2, x to the 3, x to the 4, like that. So what we can do is we can take a look at the coefficients, and a sub 1 is 1. And I was kind of determining the general term over here, so don't worry about this yet. Then a sub 0, pardon me, a sub 0 is 1. So a sub 1 is 3 over n, times the previous term. So this is going to be 3 over 1 times 1, which is 3. Then a sub 2 will be 3 over n, times the previous term, which is 3. That's going to be 9 halves. A sub 3 will be 3 over 3, times the previous term, which is 9 halves. So that's going to be 27 over 6. And a sub 4 will be 3 over 4. See, these match. There's always 3's on top. Okay, times the previous term, which is 27 over 6, and that ends up being 81 over 24. Now, if you look at these numbers, 1 we could call 3 to the 0 over 0 factorial, and you can see a pattern: 3 to the 0, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. And this looks like, well, when I saw this over here, the 2 and the 6 and the 24, those pretty much tell you that you got factorials, and this fits the pattern: 1 factorial and 0 factorial. So I actually had a general term, so I found the a sub n, and it looked like it was 3 to the n, 3 to the 0, 3 to the 1, 3 to the second, 3 to the third, 3 to the fourth, so that looks good, over n factorial, 0, 1, 2, 3, 4 factorial. So that worked out pretty good. So this was the summation. So I wrote out the first four terms thusly. So this is 1, and this is 3, okay, times x to the first, and this is 9 halves, x to the second, and 27 over 6, x to the third, plus in the general term was 3 to the n over n factorial times x to the n. Okay, letter B, what function f is represented by this power series? Well, if you look at this and regroup it, this is 3 to the n, x to the n over n factorial. If we put this together, we have 3 to the n over n factorial. What was e to the x? Well, remember, e to the x is x to the n over n factorial. So if I put a 3x there, I would get my given series. So it looks like this is going to be e to the 3x. So f of x is e to the 3x. And then they ask in letter C, find the exact value of f prime of 1. Well, the derivative of if f of x is e to the 3x, f prime would be 3e to the 3x. And if we just, that's f prime, and if we put 1 in there, we just get 3 times e to the third. So that's all we have there. Okay. All right, and I think the rest of the problems in this assignment, I think you can handle on your own, so we'll go over those in class tomorrow. So try the rest of those problems. Okay, and we can go over them, but let's see if you can get them on your own. I think you're all capable of doing the rest of the problems without any problem. Okay, good luck.